All right, this lesson is going to be on writing electron configurations. We have one goal in mind, to write electron configurations using the periodic table to do it. So if we're able to do this, it should help us to easily identify something called a valence electron. We're going to learn what that is in the next lesson, but really what we're going to focus on today is figuring out how can we use patterns in the periodic table to get electron configurations without having to draw a bunch of arrows. So that being said, what we've learned so far is that to write an electron configuration, we need an orbital diagram in order to do it. So what I mean by an orbital diagram is this image right here of the electrons in the atom. Now this image happens to be an image of the element oxygen. Oxygen has a total of 8 electrons, and those 8 electrons fit into the orbitals 1s, 2s, and 2p. If I were to write the electron configuration for oxygen, I would simply list the energy levels that are being utilized and then write down how many electrons are in those energy levels. So in the 1s level, there are 2 electrons. In the 2s level, there are 2 electrons. And in the 2p level, there are 4 electrons. So this entire string of letters and numbers is my electron configuration for oxygen. Now the electron configuration is a lot easier to write out versus drawing several, if not tens of arrows. So what we're going to attempt to do is figure out how can we go straight to the electron configuration without having to start from an orbital diagram to do it. So we're going to need our periodic tables out in front of us in order to do this lesson. I am going to be referring back to this and writing all over it, so make sure you've got your periodic table out in front of you and that you're ready to do some drawing and note-taking on it. So that being said, let's talk about how the periodic table is organized. We've learned that the shell model is a really effective tool for illustrating electrons in the atom. Now, the shell model actually mirrors the periodic table. So the way the periodic table is organized is actually the same exact way the shell model is organized. So in the shell model, I've got all of my 1s blocks on the left-hand side. The same thing is true for the periodic table. Groups 1 and 2 on the periodic table are referred to as the S block. All of the elements that fall in group 1 and group 2 have electron configurations that end in either S1 or S2. On the far right-hand side of the periodic table is a larger block called the P block. The P block has elements that are ending in P1 all the way through P6. Now there is that middle section in the periodic table that we call the D block. The elements that are present in the D block all have electron configurations that end in D1 through D10. Now, there are 2 rows to the periodic table that are so wide they don't fit in the periodic table, so we typically draw them below. However, they do reside right here between the S block and the D block, technically. These bottom 2 rows are the F block. Elements that reside in the F block of the periodic table have electron configurations that end in F1 all the way up through F14. So what we need to be able to do is look at a regular periodic table and recognize these blocks. So what I'm going to take an opportunity to do is really outline these blocks and label them on my periodic table. Now, color coding is going to be very helpful here. My 4 colors that I'm going to utilize are probably going to be highlighter colors, so that I can really illustrate the different blocks of the periodic table and distinguish them well. So what I've first illustrated is the S block. Now there's one element that's missing from it, and that is helium. Helium is written in group 18 because it has a full outer shell of electrons, but technically helium does also belong here in group 2 because it ends in S2 in its electron configuration. Now everything in group 1 ends in S1. 1. So we refer to this as the S block. Now the good news is that these group numbers match the coefficients that go in front of the S's. So I'll explain what I mean by that when I get practice using it. Now my block over here on the right is my larger block. We talked about earlier how this larger block is referred to as the P block. Now that square didn't outline very well, but that's okay. I'm going to use a different color to outline the P block. All of these elements in the P block end in P1 through P6, and those coefficients count up starting at P1 all the way through P6. Now remember, helium does not belong in the P block. Helium belongs in the S block. Now my middle block of the periodic table is called the D block. Elements that live in the D block end in either D1, D2, D3, so on and so forth, all the way up to D10. And then my last block is the F block. Elements that reside in the F block we talked about earlier end in F1 all the way through F14. So we're going to want to have this labeled just so that as we're remembering the pattern, we have this nice reminder of what elements correspond to what electron configurations. So let's get practice using this newly labeled periodic table to write electron configurations. So if I wanted to write the electron configuration for nitrogen using the periodic table, what I would need to do is find nitrogen's location on the periodic table and figure out what part of its configuration is going to come last. So I'm going to flip to my periodic table, and I'm going to notice that nitrogen is right here on the periodic table. So what I'm noticing is that nitrogen is in the P3 location. Now, since it's in group 2, that means the last part of nitrogen's electron configuration should be 2p3. Now I'm going to erase that for a moment and I'm going to zoom in on nitrogen's box. You're going to notice that that's actually listed here in nitrogen's box. So if you're ever not sure or need that reminder, you can find the reminder here on the periodic table. So what that means for nitrogen's electron configuration is that 2p3 should be the last part of the configuration, and all of the blocks that came before were filled up. So that means my 1s block was filled up with 2 electrons. If I scroll up, my 2s block was filled with electrons, leaving my next block to be the 2p block. Now I'm going to model that on this periodic table that I have here that's labeled, and I'm going to try to use a laser pointer to make this a little bit easier to model. I think I might have to change the mode here to present mode. There it is. Perfect. So when I'm figuring out nitrogen's electron configuration, what I'm going to look for is what elements came before it, and I'm going to fill that block. So the 1s block got filled up, which is why I have 1s2 to start my electron configuration. I'm going to keep going past helium onto lithium and beryllium. Since nitrogen is past that, that must mean that the 2s block was also filled up with electrons. So that's where my 2s2 came from. And then since nitrogen's in the p block, but it's only in the third space, nitrogen should have 2p3 for the final part of its electron configuration. And this would be my final answer for nitrogen's electron configuration. So let's do the same thing for bromine. I'm going to do the same thing for bromine, and I'm going to find where bromine's location is. Looks like it's right here, element 35. So I'm going to fill up all the preceding electron configuration orbitals that come before bromine. So 1s is going to get filled up with 2 electrons. As I go back, 2s is going to get filled up with 2 electrons. The 2p block is going to get filled up with 6 electrons. I'm going to keep going. Now I'm over here at 3s. Notice I'm counting up by atomic number. So once I filled up that 2p block here, I'm moving on to element number 11, and that's how I'm getting to my 3s block. So the 3s block got filled up with 2 electrons. I'm out of the 3s block. I'm moving from element 12 all the way over here to element 13. Now I'm in the 3p block. Notice my 3 and my p's is how I figure that out. The entire 3p block is going to get filled up with 6 electrons. After element argon is element potassium, so I'm now in the 4s block, and that's going to get filled up with electrons. And here's where things get interesting when I get to the D block. So the D block has an interesting pattern. Instead of having the coefficient that is my period number, like 4D, the D block is one number behind. So this would represent 3D1, 3D2, 3D3, 3D4, so on and so forth. So this entire row right here represents the 3Ds, and there are 10 of them. So that means the 3D orbital is going to be filled with 10 electrons. That means bromine right here is in the p orbital. Now the p's have the same coefficient as my period number, so these do correspond to 4 p's. My counting goes back to normal. Since bromine is in the 5th spot, bromine's ending corresponding electron configuration should be 4p5. And this full string of numbers and letters is bromine's electron configuration. So let's do one more together. My periodic table has gotten a little sloppy, so I'm going to clean this up a little bit. Let's do this again for chlorine. So chlorine is located right here, element number 17. So that means I've filled the 1s block with 2 electrons. I'm going from element 2 to element 3, which is in my 2s block. So I filled up my 2s block with 2 electrons. I'm moving from element 4 to element 5. This is the 2p block, and I filled that up with 6 electrons. And then I'm moving on from element 10 to element 11. That's the 3s block. So I filled the 3s block with 2 electrons. And then I'm jumping from element 12 to element 13. Chlorine is in this block, and this is my 3p block. So all of these are 3p's. And since chlorine is in the 5th spot, then that means the ending part of chlorine's electron configuration should be 3p5. And this would be the electron configuration for chlorine. So again, we want to be able to look at the periodic table, look at where elements are on the periodic table, and write their electron configurations. So that being said, we've got 3 tries right here. What I'd like you to do is attempt them, pause the video, and when you're ready to check your answers, unpause the video. I'm going to assume that if you're watching this, you have attempted these 3 tries and you're ready to check your answers. So let's get started with carbon. Carbon, I'm going to erase some things here, make it cleaner. Oops, erase a little bit too much. Carbon is in the 2p2 spot. So that means that carbon filled the 1s block with 2 electrons. the 2s block with 2 electrons, and the 2p block with only 2 electrons. Let's move on to krypton. Krypton is in a different location. Krypton is right here, element 36. It is in the 4p6 location. So that means that krypton should end in 4p6. So it filled the 1s orbital, the 2s orbital, the 2p orbital. It filled the 3s and the 3p. And then it jumped to 4s. And in between 4s and 4p is the 3ds. And then last but not least, it ended with 4p6. And then the last one is sulfur. Sulfur, I'm going to try to make some room here. Sulfur is in my 3p4 location. So that means that sulfur filled the 1s block, the 2s block, the 2p block, and the 3s block. And the last part of its configuration is 3p4. So you might have noticed that for some elements, this is pretty simple. Like, for example, carbon is a pretty short string, whereas an element like krypton is a much longer string for its electron configuration. So when we're working with elements that have a lot of electrons, such as krypton, there is a simpler way to write electron configurations, and it's actually on the periodic table. So I'm going to zoom back in to nitrogen, what I referenced earlier. At the bottom of nitrogen's box, there is this little code right here. I'm going to highlight it a little bit more intentionally. Helium in brackets, 2s2, 2p3. What this represents is a shortened electron configuration. We call it the noble gas electron configuration for nitrogen. What this string does is it essentially allows us to shorthand write electron configurations. So for nitrogen, it doesn't save us too much time, but if we remember krypton, how long krypton's string of electron configurations was, the shorthand for krypton is significantly shorter than the longhand. So for certain elements, we're going to see that this definitely saves us time. So let's practice figuring out how do we write what's called a noble gas configuration. There we go. So what we're going to do when we're finding the noble gas configuration for an element is look to our noble gases. The noble gases all have something in common. They have a full outer shell of electrons. So it's ideal that we use the noble gases to abbreviate because they represent the core electrons inside an element. And then everything outside of those noble gases would be considered an outer electron. So if I wanted to write the noble gas configuration for sulfur, sulfur is located in this box on the periodic table, and I'm going to actually write that with a finer font right here. Now, sulfur's normal configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Now, if I wanted to abbreviate this, I'd have to figure out first and foremost what noble gas comes before sulfur. So sulfur is element 16. Argon is element 18. Since this comes after sulfur, this is not the noble gas we want to abbreviate with. We want the noble gas that comes immediately before sulfur. So neon, being element number 10, is before sulfur, which is element number 16. Now, neon number 10 abbreviates all the electrons in the 1s block, the 2s block, and the 2p block. In other words, it abbreviates this entire part of sulfur's electron configuration, leaving only 3s2 and 3p4 unabbreviated. So when I want to write the noble gas configuration, I don't have to write all of the electrons. I can just start with the noble gas that comes before that element and only write the electrons that come after that element. So this is going to be our goal moving forward, is writing noble gas configurations to save us just a little bit more time. So let's get some practice with some of the elements that we were working with before. So nitrogen on the periodic table is element number 7. If I want to start with a noble gas configuration, I need to find the noble gas that comes not after, but before the element I'm working with. So I need a noble gas that is before element number 7. So I'm going to look to my periodic table, and I'm going to see that nitrogen is right here. Neon is number 10. It comes after nitrogen, so I'm not going to use neon. Helium, however, is element number 2, so it comes before nitrogen. So this is the noble gas that I'm going to abbreviate with. So I'll start off my noble gas configuration by abbreviating helium, and then I'm only going to bother to write what comes after helium. So after helium is my 2s block, and then my 2p block. Since nitrogen fills up the 2s block, that would be 2s2, and since nitrogen's in the third spot for the p block, that would be 2p3. So in my noble gas configuration, I'm simply going to write 2s2 and 2p3 after helium. So it saved us a little bit of writing, but not much. Let's try a bigger element like bromine. Bromine is element number 35. So I need a noble gas that comes before element 35. So bromine is located right here, element 35. Krypton is element 36. Since that doesn't come before 35, this is not the noble gas I want to work with. The noble gas that comes before element 35 is element 18, argon. So I'm going to start bromine's noble gas configuration by abbreviating argon. And I'm only going to write what comes after argon. So after argon is the 4s block. That will get filled up with 2 electrons, followed by the 3d block. That will be filled with 10 electrons, followed by the 4p block. And since bromine is in the 5th spot, that'll be 4p5. So I'll write after argon, 4s2, 3d10, 4p5. So that actually did save us quite a bit of time. So let's do one more together. Let's do chlorine. Chlorine should be element, if I'm not mistaken, I think 17. Let me look on the periodic table. Yes, it is. So since chlorine is element 17, I need the noble gas that comes before 17. That's going to be element 10. So argon comes after chlorine. That is not what I'm looking for. I need neon because that comes before chlorine. So I'll abbreviate neon in brackets, and then I'll only write what electrons come after neon. So my 3s electrons, and then my 3p electrons. So my full noble gas configuration would be neon, followed by my 3s electrons, and then my 3p electrons. So there are 3 tries here below. Go ahead and pause the video and unpause when you're ready to check your answers. I'm going to assume if you're watching this, that means you are ready to check your answers. So let's go ahead and try this. Carbon is going to be abbreviated with helium. After helium is 2s2, 2p2. Krypton is a noble gas. However, I can't put krypton in brackets. I'm going to have to abbreviate argon and write everything that comes after argon. So this was a tricky one. So 4s2, 3d10, 4p6. Now you're going to notice that on the periodic table for krypton, they wrote krypton string in numerical order. That's fine. You won't get marked off for writing it in numerical order. So that leaves our last one, sulfur. Sulfur's element 16. So the noble gas that comes before 16 is neon. After neon is our 3s block, and then our 3p block. So that concludes the notes for drawing, or rather writing, electron configurations. What you should be able to do now is look at the periodic table, and from the periodic table, write a string of electrons and their energy levels that they reside in. So that being said, collect a practice assignment and go ahead and practice what you learned in today's notes.